Hi, I'm going to go over how to derive the double angle formulas for a trig. If you're somebody like me who doesn't like memorizing a lot of special case trig formulas, this is actually a pretty good way of deriving those formulas, the double angle formulas. What I do consider very important to memorize is Euler's formula, which states that e to the I theta is equal to cos theta plus I sine theta. That's something you should never forget. And what we're going to do is go ahead and look at the case where you have e to the 2 I theta. Well, we could look at this as our angle being 2 theta, which is cos 2 theta plus I sine 2 theta. Or we could look at it as e to the I theta being squared, which is cos theta plus I sine theta minus squared. That's actually de Moivre's theorem right there. And so, if we go ahead and expand this right over here, we have, for our real part, cos squared theta, right? Minus sine squared theta. And for our imaginary part, what do we have? We have cos theta times I sine theta taken twice. So that's 2 cos theta sine theta times I. Okay. And equating real and imaginary parts, we see that the cos 2 theta is equal to cos squared theta minus sine squared theta. And the sine 2 theta is equal to 2 cos theta sine theta. So, like I said, that's just a quick way of deriving double angle formulas. There's a more general case where we're not just looking at a double angle formula, but let's say we have cos alpha plus beta. And there's a way to get that. I'll go ahead and erase this. What we do is we consider, here's your real axis and here's your imaginary axis, right? We consider a line of length 1, right, where you have your angle alpha here, and we want to rotate it through an additional angle beta. So it's now up here, right? And so we take this line. Now this line is, let's see, we'll write this as a matrix. We have cosine alpha, right? And our imaginary part is sine alpha. And we want to rotate through that through an additional angle beta. So we use the rotation matrix. Again, something you should memorize. This is cosine beta minus sine beta. And we have sine beta and cosine beta. Okay. We perform the matrix multiplication. So that'll be cos beta times cos alpha. Right, cos alpha. Cos beta. Minus sine alpha sine beta. Okay? That's what goes on the top part of the matrix. And for our y coordinate, we have, or our imaginary coordinate, we have sine beta cos alpha, right? Or cos alpha sine beta. plus sine alpha cos beta. Okay. And now that we took this vector right over here, cos alpha, sine alpha, and rotated through an additional beta, that should give us, if this is equal to cosine alpha plus beta, sine alpha plus beta. Okay, so cosine alpha plus beta is equal to that right over there, and sine alpha plus beta is equal to that. Which, if you let alpha equal beta, you're back to the double angle formulas. Anyway, I just thought that was a neat little trick.